Here's another question brought to you by Martin Tutorials. As a reminder, I have two YouTubes, Variety and Fun Math and Martin Tutorials. Variety is all interesting topics and math that interests most people. Martin Tutorials is only mathematics. As this question is arguably more advanced, it's only going to Martin Tutorials YouTubes. Both YouTubes are free to subscribe. And as always, if you're not happy with the free subscription, you get a full refund policy. And here is my question. We have a floor that's 9 meters long. We have a light at the end here. We have a cat. I just chose a cat that's 20 centimeters high. And the cat is walking towards the wall at 1.5 meters per second. And the question is, how much is the shadow going up the wall when the cat is 4 meters from the wall? So when this cat reaches a point where it's exactly 4 meters between the cat and the wall, at what speed is this shadow going up the wall? The one thing I do notice with this question, some of it is in centimeters and some of it is in meters, and I cannot work with both. I've got to either convert meters to centimeters or centimeters to meters. And I can actually choose either. The advantage of using meters, it's smaller numbers. The advantage with centimeters, we do away with fractions or decimals. I happen to choose centimeters. So instead of saying it's going at 1.5 meters per second, I said it's going at 150 centimeters per second. We times by 100 to convert from meters to centimeters. Okay, and I always say there's 3 rates of change. The one that's given, the one we need to find out, and the third one which relates it to, like dh over dt. Oh, I forgot to mention, I decided to call that h for height. I could have used any letter, but h is easiest. The distance from the light to the point where the cat is, I happen to use x. I just chose that letter because I'm used to it. There's no rule saying I have to use x. Okay, so dh over dt is what we have to calculate, the rate of change of h. dx over dt we are given. I happen to change it to centimeters, and we have to find something that relates h and x, because to cancel out those x's to leave us with dh over dt. And this is like chain rule. Like dh over dx is a function with h and something being done to x. And within x, there's another function. We times it by that derivative, which is dx over dt. Like, let's say x equals t squared plus 1. I'm making that up. The derivative of this would be 3 times x squared times the derivative of t squared plus 1. That's dh over dx is that derivative, times the derivative of the inside function, which is dx over dt. So it's like chain rule, but h and x is what we need to link up. So what I do is I find a relationship between h and x. I see similar triangles. This triangle and the big triangle are relative to each other, the same triangle. It's a different size, but they're similar. The parts are the same relative to each other. So 20 divided by x is the same as saying h divided by 900, because I converted that into centimeters, because that in the big triangle, that 900 is a constant. Okay, so there's my equation. H over 900 equals 20 over x. I isolate h. H is 20 times 900 over x. 900 times 20 is 18,000. And instead of saying divided by x, I say times x to the minus 1. It means the same thing, but for doing derivatives, it's easier to work with. So dh over dx, the rules of derivatives, I bring that minus 1 there, and I subtract 1 from the exponent. Minus 18,000 x to the minus 2, which is minus 18,000 over x squared. And I am an idiot. I converted it back to minus 18,000 x to the minus 2. I brought it back to how it was. I thought, hey, it looks nicer over here, and hey, let's put it back into this form. I mean, I mean, they're all correct. I've done the derivative, so I don't have to decide which is easier. Okay, so now this equation which I had over here, I'm going to rewrite it. dH over dt, I don't expect to know now because that's what we have to work out. dx over dt is 150. That's centimeters per second. It was the 1.5 meters per second that we had converted. And dH over dx, we have as minus 18,000 over x squared, or minus 18,000 x to the minus 2. Well, here I happen to write it in with a minus x to the minus 2. And the next step, I brought it underneath. I should have kept it at this point because that's what I used. But anyway, so it's minus 18,000 x to the minus 2. And if we do the arithmetic, that's minus. We multiply these two numbers, the 150 and minus 18,000. We get minus 2,700,000 over x squared. But here's a little trick. We have to be so careful. Okay, I rewrote the minus 2,700,000. We were told when the cat is 4 meters from the wall. Now let's look. There's a cat 4 meters from the wall. I called x between the light and the cat at the beginning of the question. So I must be careful not to plug the 4 in, but the 5. And I have to convert to centimeters, we'll be working in centimeters. So that x squared becomes 500 squared. So it's minus 2,700,000 divided by 500 squared. And if I simplify it, it's minus 10.8 centimeters per second. And I'm not surprised that it's a negative, because when this cat is walking, that light will be going down the wall. Now, I always have to make sure my answer fits the question. I have two correct answers. I could say it's going up the wall at minus 10.8 centimeters per second, or it's going down the wall at 10.8 centimeters per second, because the positive number is correct using the word going down. Well, I answer the way they asked it. They say, how much is it going up the wall? So the correct answer is it's going up the wall at minus 10 centimeters per second. And also the actual question that gave us some centimeters, some meters, but they did not in the question tell us how to answer. So we can use either. So the correct answer is it's going up the wall at minus 10.8 centimeters per second. That's another question brought to you by Martin Tutorials.